Hello everyone, I'm Xiaogan. Today, after a previous learning, you'll find that writing this class is very painful, especially every time we define a struct. We have to write a bunch of code like this. So is there a way we can just define the properties inside the struct without having to write the serialization and deserialization process? Of course there is. Unreal Engine has already done this part for us. Next, I'll show you how to do it. Then we'll put the method below. Let's call it good. Good structure. Okay, so let's create this method first. Okay, we need to create our struct. This struct needs to carry reflection information. Let's take a look. Let's create a simple one first. Let's create the struct first. Let's put it below. We need a UStruct because this system relies on reflection to work. So if you need these properties to be serialized, you need to attach this macro to it. And here we need to attach a generated body. Then for now, let's not make it rough. Let's not make it rough for now. Okay, then we can just give it an up. Okay, if you need to. You can expose these to Blueprint. We don't need that now, so we won't expose it to Blueprint. Yes, because we are only testing here. Then remember what we said earlier. You cannot write this kind of TL. That is, if you are TL Railway, this container nesting approach cannot be reflected to Blueprint, and for a struct, it cannot write what functions. Remember these 2 points. Let me emphasize one more point here, because this is relatively basic knowledge. Don't forget. Then next, we will take this. F, we need to start. Then we give it a simple little rigid body. Then what do we do next? Here we declare such a struct. We call it server info. Now, if we want to convert it into a struct, how do we do it? We can use this. We have a JsonObjectConverter. Such a converter. Then it is here. We can have a UStructToJsonObject stream. Then it converts a struct into a JSON stream. We can see its parameters. We teleport here. Then we need to prepare a word count. We call it server info.json. Okay, so that's it. It can then be converted over. We take this attribute, we make a modification. At the same time, we use this method, write an attribute. We call it not serverize. Not serverize. Let's call it laterite. Laterite to take the IT attribute. Okay? Let's call it the laterite attribute. This property will not be serialized. Then we find the value at this location and assign it. We will name this XG server. Then next, its version. We give it 1.2.3. Version 1.33. Then we give it a laterite. We call it txt, not serialized. Then we give it another value here. Give it a test value. This test info we also did not initialize, although we know it will be initialized. But we did not give it an initialization. We haven't taken simple responsibility for this either. So what do we do next? Then we can see this place. Actually, this will convert the video. So this is a serialization process. Yes. So how do we deserialize it? Actually, deserialization, we've written them together here because it's relatively simple. Let's copy this video because we need to distinguish. We call it bank. So for the bank here, after we copy it, we can have this function. We declare here simultaneously called bank server info. This is fine. Okay. Then we still use this structure. This structure of ours we use. The two methods we use most often are these: parse object, parse object string TUStruct. And here we need to put this string in, put it here. Then we put this UStruct here. Okay. Here we might need to take an address. Okay. It will serialize this information back. Right. Then we can take a look. After serialization, what these two structs look like. Okay. We'll just give it an inner sensor. A equals 1. Now let's start it. Okay, let's set a breakpoint for everyone. Okay, we have already entered the section here. After we have such a struct, then you can see that this struct, it currently looks like this, right? And part, not serialized. Then let's see what it looks like after serialization. Okay, so after serialization, this saves. You will notice it only serializes two properties that have values. And this test info, it serializes an empty slot. You can see, then this header, right, it was not serialized. Then here we come over here, then we deserialize it again. When we look at our deserialization, this struct, whether it behaves as we expected, you will find this deserialized struct is exactly as we expected. And the property without this red marker, it was not added in, okay? Alright, note that because here, there will actually be a warning. We turn on this vortex shadow here. It's not here, right? If it's not, then forget it. Actually, we turn it off. Actually, you'd better give an initial value to the values here. You'd better give an initial value. Don't leave this value empty here. Although I know uProperty will help us initialize it, it's better to give a value. Okay, so this is a simple way to do this through ObjectConverter. Now, let's guide you to complete this. Go and finish this thing. Let's see what this thing looks like when it's done. We still need to take a look at the instances connection. Find our connection here. We call this the message connection. It should be this one. So the part here is done. Let's see how we should write it if it involves object nesting and hosting. Let's write it like this. Let's go back here and define the struct. This struct is actually quite easy to define. Let's paste 1 first. Paste 1. Let's call it simple. Message info. Then here, the first one is obviously a code. So it is an intercessor. Okay, then the second one is our message. The third one is our data. Okay, this lose right. We leave it empty here. You can write whatever you want. It doesn't really matter. And this is actually the side. Personally, I prefer you to manually roughen it, because this avoids some uncertainty. Then next we write this info. This info is actually it. We can just put it here directly. Then its name is info. Okay, because it's a struct, so you can just write it like this here. It's the default constructor. And here, there's a work ID, right? Obviously, this is a TArray. Here, it's an intersensor TArray. Then next is a coder. This coder is a bit troublesome. We need to define a struct first. We need to borrow it. The first thing in this coder is this lamb, right? And the second is this float. It's better to use double. Code work year. So the name here must match. Because if it doesn't match, it won't be found. So the name here must be the same. need to emphasize this. Okay, so this is actually a tear position. That's it. Okay, then it can satisfy our requirement for serialization. Okay, we'll give it an object. Right, you can see, this time using TArray like this, and then there are two such objects inside tree. Then we go back to this method of ours. We call it google.struct.JsonToUstruct. Here, we first do the same. Let's see if there's something written wrong here. It seems the name here was forgotten to be changed. This is called coder.info. Let's change it here. The reason here is like this. Here, that's correct now. First, we still need a struct like this. This struct is called message_info. Then we can modify the diameter inside. We set it to 1,037. I don't know what phone number this is. And then, this information here. We can just leave it blank for now. In order, these few words don't count. Let's just write it up. Test information. Remember, actually, our current encoding is T. J. Our network transmission still needs to be converted to. Later when we'll just demonstrate for this data. It seems like we have an F stream. Let's just give it a B1. And here, actually, in the previous section, we talked about the commercial approach. We can actually do it this way. It's fine. And then here, next is our side. Seed, we all 7352 4节152 415 Okay, then we need to assign a value to this info. First, we bring up info. The name here must be the same. If the name is different, it won't be recognized. You see, like if it's servation, then actually in the struct here, it should change the name here to be the same. Otherwise, the serialized name will be incorrect. Let's change this one in front. It doesn't matter. So in this place, it matches through reflection on the variable name. That's why you'll see in some of my projects it's written. This lowercase one is very normal. Let's call it like this. This cell line, let's give it 1.3.4. Okay, then here, we treat this as equivalent to this part here. Let's get this struct set up properly. Now, we're working on this host. Let's just add it directly. Let's give it 246, 146. Then, over here, we work on this coder. For this coder, we need to do it this way. For the coder, click this to add an element. Actually, if we had a constructor here, we could do this implicit conversion. If we don't have it here, we'll ignore it. We get this one, this one. Then here we use last to get the last one, the most recently added one. Then we click its lam. This page. Then here we also need to click a property. Okay, we set this to 3.2. This is a double, right? Don't worry about it. Let's do it again like this. Do it again. We go GX. Then here it is 1.3. Okay, so now we have a struct. After we serialize the struct, we can send it to the front end or to the backend, whichever we want. Don't worry if you can't follow or anything, because this thing, actually, we have about 4 or 5 chapters later. And each chapter will cover this. Just follow along and write a few more of these with me, and you'll develop a conditioned reflex for it. It's really that simple. Okay, then note here, to deserialize it back, we should pass this in, then deserialize it into this. Okay, then let's set a breakpoint here. Then let's start it up for everyone. We have now started it up. There is a plugin here. Let me show you. Actually, it has some plugins derived from UEC. That is, Blueprint hits this user. You can take a look. There is also an HTTP. Actually, right. This is the latest version of UE5. It provides some plugins for use with Blueprint. We don't actually use this plugin because you'll understand it at a glance. This is relatively simple. I haven't looked at it yet either, but this is very simple because what we're doing now is essentially developing this set of tools for our own project. Why do you say that even with the plugin? We still need to develop our own. It's like having wearways and you still develop your own. It's because there are some things that you must customize. For example, you might need streaming transmission. You might need upload and download. These kinds of general purpose plugins you have no way to support or of your features. So you still cannot avoid doing this kind of customized development. So it is based on this reason. Therefore, this content is extremely important. Okay, let's take a look here. Let's set another breakpoint. Let me see if this is fading out. Take a look. Why doesn't it seem to be executing? You'd pick up 2, put it here. Alright, it should be Google Stack Pickup 2. Let's execute it directly here. We press 1, then it comes in. You can see we have defined some structs here. Then we assign some values to its properties. Let me show you after we finish defining it. It looks like this. You can see, no problem. We deserialize it. Hey, isn't it simple? Right. This serialization. This result is exactly what we expected. It meets our requirements. It's also not a problem. Then here we are. Jailer it back. You can see that this struct, the struct is abstract. Take a look. Right. Just now, maybe the info server. Lam. It seems this value wasn't put in here. Let's check what the reason is. Very simple. The reason is that we wrote it wrong here. Actually, there is a Boolean value here. That is, success or failure. Actually, this is a failure here. Yes, a touch fail here because the context of this connection failed. This situation usually occurs when you access the wrong interface. So this is a failure here. Then let's change this. Let's make the change now. Okay, let's put it here. It might not necessarily fail in other cases. It could be that the property was not found, etc. There are many such reasons. I'll use the one that calls the monster. We need to change it like this. Only then will it work. Good. This is a very good error. It just demonstrates to everyone. Actually, there are some other methods here. You can take a look on your own later. Because there is another method. If we were to talk about it, you can convert it to a direct object. Then, converting it to a direct object actually has an advantage. That is, it gives us a higher degree of freedom. Because right now, it's all packaged for you. Okay, you can see that the properties here have also been transferred through network transmission. Alright. Actually, the two we use most often are these. The most commonly used are these two. These two. Let's go back. These two. But sometimes there are some special cases like this. It's the constraint it returns. It doesn't have a complete node. It might return 10 nodes. These 10 nodes, they are packed together and returned to you. So sometimes you can consider using this method. It has a JSON array string to extract. This is still a string, but it's a JSON array string. Then it will be initialized into this, a struct of a TArray. This is where you load the input into this TArray. And essentially, it's not much different from this right here. You just need to change this input string. It might be that when it's input, this is 1. It could be like this. Like this, you can see. It might be like this. And here, right here, we'll paste it. It could also be like this, right? Look, this is a JSON. It's a Cajun array. You can see. Maybe we can parse it here. Not sure if we can parse it out. See, it doesn't parse. You see the parse. It parses out. Actually, look at this. This way, it can be serialized into 1 or 2 structs. That's what it means. We won't delete it here. Just keep it here. We don't need to demonstrate it to everyone either. This is also quite simple, right? Okay, so let's stop here for this review session. That's all for this chapter's review, because this review will be used in every chapter afterward. Alright, we've covered most of what can be explained, and there's one special case, which is the value he provides. If this value is missing, or if the value is too high or too low, this value will appear in a default state. So we need to provide a default value. If we find it's the default value when using it, it might mean that during this transmission, this value is in a default state. It cannot perform this kind of let me pause for everyone. Pause for a moment. Something like this. That is, you can see, actually, there is a class called T in the engine. Wait a moment. It should be. I don't quite remember. It should be something like T optional, an optional type. It seems there isn't. Let's look for it. There is a T optional here. Such a thing. What is this thing? It is a... We explain that this value is, if it is a pending value, that is to say, before you set it, this value has no meaning. That is, if you retrieve this value, that is, after you retrieve this value, it only becomes meaningful after you have set it. If it has not been set, it is not meaningful. So retrieving it has no meaning. So this T optional is, but this thing does not support reflection. So you cannot reflect it in Blueprint. So when we design, do not use this kind of advanced syntactic sugar. Because this kind of syntactic sugar, if your better needs to serve Unity or UE, Unity might have T optional as a setting. This kind of syntactic sugar may not exist in UE. Maybe UE also has it because C++ is definitely more low-level and easier to use than all other programming languages. But it may not be able to reflect into Blueprint because Blueprint is equivalent to visual programming and it inevitably has some default values. So this thing cannot be reflected into Blueprint. It would be difficult to implement on your end. Therefore, you should not design such default values. You give it all a default parameter value. If it, for example, doesn't output, you can understand it as null or something like long. Actually, our course is actually quite powerful. Our serialization, right? So what makes it powerful? We can serialize some time. Actually, we can set a breakpoint for it. Let's add a class for it. Let's add one and call it. Actually, you can, right here, we add a 68F data time. Get we'll give it dump time. Okay, now if we set a breakpoint here, we give it an empty child. Okay, then when we serialize here, we give it a value here. It should be called this. Actually, an enum is also fine, but with an enum, you must pay attention to its corresponding enum value. The enum values on your front-end and method must be consistent. Okay, now let's observe again our serialization and deserialization. This string, then on my end, we will wrap up as soon as possible. We will cover this part in this chapter shortly. Okay, now let's start it. Okay, we are in. Then let's observe carefully. Here you can see, this time is actually this. But after we finish the serialization, you will find when you pull down this diagram, the serialization originally looked like this. Actually, because of reflection, there are actually many things we are all reflecting. It does it for you. So adjusting this is very convenient when we interpret it. Right, look, we serialize it back. We serialize it back again. It should be this structure. You can see, actually, this time has already. It is this. So this is really convenient. Okay, let's stop here for this chapter. We will bring in later. to explain to you. This saves in network transmission. How should we use it correctly? For example, if we want to transmit some binary data or transmit some images, transmit some audio, then how do we integrate it with JSON? How do we upload and download in the network? All of these need to work with JSON. Okay, thank you everyone.